Okay, it's recording. All right, team. So exercise 8D, this one is actually, most students pick up. Listening. Most students pick up on this. And Zach, can you come and grab a sheet so you got something to write on? Most students will pick up on this on the first two examples. The next two, I often find in the test that students tend to then make mistakes. And then the last few is when students feel like, I've never done this before. Okay, so I did that with my year 10s. It's the same thing. Year 10s will come in and they'll need a bit of a brushing up on how the rule works, and they'll be masters within a few seconds for the first two. Then I give them C and D, and they're like, and they'll get it wrong. And then I teach them after the four simple examples, they'll then be able to do these two. Okay, so look hard, but the same technique. So you stick to the same layout that I'm showing you, and you should be able to do even more complicated ones than that. It's a very typical skill that they use at Year 12 methods exams because they know most students forget or don't know how to use this rule. Okay, this is how simple it is. Just up here, this is called difference of perfect squares formula, which you've seen in the previous example of 8a. So that's a perfect square. Remember, a squared. A squared just means that you're squaring a certain value. If you had to think of a perfect square, you're just simply saying length of A on the other side, and when you say A squared, what you're really working out is the area. So the area of a perfect square, subtract another area of a perfect square, that's why they call it difference of perfect squares. What we found out is that if you multiplied by the length of A, subtract by the length of B, okay, you multiply that to the same thing, length of A plus the length of B, it actually ends up being the same as saying the square of A, take away the square of B. That's where the theory is coming from, okay? All you need to remember, A squared minus B squared is equal to, and you got A minus B times A plus B. That's your one key rule for DOPS. When you use DOPS, the key point that I want you to focus is every time you get a square and then you see a minus, that should be a hint to you that you could use DOPS. Here's examples. If you have a look, square, take away. Square, take away. Square, take away. Square, take away. Those are hints. So when you get to year 11 and 12 and you do methods or algebra, you notice there's always a square and a minus. That's a hint. There's going to be DOPS. Okay? So how does it work? Well, with literally, if you can rewrite any of these expressions here in the same way that you see up here, something squared minus something squared, then you simply fill in what A is and what B is. So here's how the first one works, and most students will pick up on it, and I'll show you. You'll be able to do probably 6, 7 different ones in your head. Okay, so here we go. Here's the first one. You need to rewrite this and copy this down. I want you to copy the layout. Something squared minus something squared. Okay, there's always this intermediate step to help you visualize what's happening. So, square of what? The question is square of what in this box here to give you the first term, which is x squared. What would I square? Square of what will give you x squared? Yeah. The square of x will give you the first term, which is x squared. Then I ask the same question again. I say, the square of what will give you 9? 3. So then we put in 3 in here. Now, for those who aren't sure, what we actually did there is, if you didn't know the square of what, then you can think of it as root of 9 gives you 3, and the root of x squared, the root and the square are opposites of one another. Squaring, square root are opposite operations, so hence they cancel out, and the x goes here. Okay, so every time you want to figure out what goes in the brackets, you're literally just square rooting both terms. Okay, now, once you've got it in this form, that's it. That's the hardest part. If you can write it in this form, then writing the answer now becomes easy. Because remember the rule, if you have a look at the rule again, it said a squared minus b squared. So that means my a, so if you have a look at it again, my a must be x, this is my a, and then minus b must be 3. Can you see that? So if that's true, then the bracket, the answer should be then a, which is x, minus b, which is 3, and then a again, which is x, plus 3. Because all you needed to figure out was which one's my a and which one's my b. And this is my a, this is my b. Can you see that? And the reason why I put the brackets is because later on, the harder examples, if you can put in the brackets, then you know what's inside the brackets, then you know what a and b is. That's why it makes it easier. Okay? So far, students will start to pick up. 9 becomes a 3, so they go x plus 3, x minus 3, pretty easy. Then I go to the next example, and then most students will start to get the feel. So here we go. Same thing with the next one. This is x squared minus 16. So if I asked you to write it as DOPS again, this is what you do. Something squared minus something squared. So I ask the same question. Jaden, square of what will give you x squared? X. And then let's go with Jake. Square of what will give you 16? 4. So now that you've got your A, you got your B, according to the rule, A, which is x, so it should be x minus your B, which is 4. A again, which is your x, plus whatever your B is, which is 4. So far, so easy? Yeah, so what you're saying, what's the pattern? When it's 9, it's 3. When it's 16, it's 4. So it's x minus 4, x plus 4. So I can give you this now. Within 10 seconds, you should be able to do these ones in your head. So if I gave you this, what about x squared minus 25? What should the brackets be? X and 5. So it should be x minus 5 and x plus 5. Let's try another one. X squared minus 36. What should be in the brackets? X minus 6 and x plus 6. That's how easy it is. That's what I'm saying. So most students will be able to do this, and you go through your textbook, you're like, too easy, too easy, too easy. And then I give you this one. Okay? Shh. So you got the first one. First two is pretty easy. Feeling comfortable? Next two. Shh. Here we go. Next two. Same drill. The examples look different, but it's the same concept. The mistake that students do here is not the 9. Most students will be okay with the 9. It's this one. They get that one wrong. So I want you to make sure to, again, put in the brackets. Copy this down. Put in the brackets something squared minus something squared. So here we go. We do it again. Last one's easy. Square of what gives you 9? 3. So we know this is 3 here. But then this is the one that students might make a mistake with. Square of what gives you 4a squared? Yeah, and it's not 4a. So a lot of students write 4a, but really we need the square of something. So you times itself, it should give you 4a squared. The logic to it is if you square root it, you'll be square rooting the 4 and you also square root the a squared, and those two cancel out. Hence you end up with 2a. If you write it this way, it becomes much clearer now. Which one's my A and which one's my B? So here clearly is my A. That's my B. So according to the rule that you've copied down so far, the bracket should then be 2A, which is my A, minus B, which is 3. And again, 2A plus 3. How do we feel? Very good. Sorry, Millie, you can grab a copy up here. There you go. Okay. Now I want you to have a look at the second example. Same drill. Sorry, fourth example. Same drill. So C and D are similar. Think about it. So think in your mind. What would I put in the brackets? And I'm going to write it out again. Something squared minus something squared. So we follow the same pattern again. Here we go. Square of what will give you 25a squared? Let's go with Reese. 5a, correct. Well done. So square of 5a, so 5a times 5a gives you 25a squared. Great. And then square of what will give you b squared? Let's go with Steph. B. Well done. Now that you've got what's inside this bracket, you got what's inside that bracket according to the rule, same thing again. It'll be 5a minus b, 5a plus b. How are we feeling? Pretty good? This is exercise 8D. It's called factorizing by DOPS. You don't always get this, but they will throw it hidden. So you'll learn all these other extra techniques, but this is one that students tend to forget. Though it's easy, they forget the technique. Okay, here we go. Last two, boys. Last two, so I've now upped the ante a bit. Let's have a look at the last two. And that one, even though it looks scary, it's actually meant to be easier than every other one. So here we go. This one, the reason why students find this tricky is because unlike these ones, they were all squared numbers. 25, 9, 4, 36. Those are squared numbers. When you don't get squared numbers, there's actually two ways that you could look at this. One, always look for factors that are in common. Sometimes it makes your life a bit easier. What I can see there is they both have a 2 in common. So what you learnt in the previous exercise was you could rewrite this as take out the factor of 2 and you get 2 times what will give you 2b squared. This has to be a b squared there. 2 times what will give you a 32? Well, 16, and there's a minus there. You see by factorizing, Jake and Jaden, thank you. By first factorizing common factor, this makes your life easier, and inside the brackets, this is a difference of perfect squares problem. See, this has a square and it has a subtraction. As soon as you see that, you should think of difference of perfect squares. So if I were to write this, I'd keep the 2 on the outside. I'm going to use a square bracket so that you can see that I'm doing the same techniques again. Something squared minus something squared. Same drill. Square of what will give you the b squared? Square of what? Let's go with b. Square of what will give you b squared? Sorry, I'm asking, something times itself will give you b squared. What would that number have to be? So this goes b. Let's go with the next one. Yeah, sorry, I called you b as well. 16. Something times something gives you 16. What is that, Zach? 4. Very good. So we know that it is b squared subtract 4 squared. Now, once I've rewritten this expression as this, you can follow the difference of perfect squares again. Follows the same thing. Keep the 2 on the outside. And inside the brackets, we know this will follow b minus 4 and b plus 4. Same drill. So this is b minus 4, b plus 4. Can you see why students tend to make a mistake on this one? Because it has that one extra step that students aren't familiar with, whereas all the other ones, you start to feel a bit more comfortable, right? So that's just within the brackets. So look for a common factor. That's what I would hint out. You can do it without using common factor, but unless you're strong with square roots, then it might be a bit trickier. Okay? Now the last one. I'm going to leave this last one for you to try. So I'm going to do this one as my last one over here. A lot of students, when they first see that and I put it on a test, it's blank. I often get about 10% of students who answer it, and those 10%, I may only get 2 students who do it, so 10% of it, and then only one of them get them right. But this is actually really easy. This is how it works. Same drill again. Something squared, take away something squared. Thanks, boys. Don't speak while I'm speaking. Something squared, take away something squared. And the reason why I say this is actually easy is because have you noticed the first bracket? It's already something squared. You don't have to do anything. It's already in a bracket squared for you. So the answer is still x plus 2. You didn't have to do anything. The only thing you had to change was the 9. 9 was the only one you had to change. So 9, square of what will give you 9? And we know so far it's 3. So now if I asked you to put it in brackets just like with the rule that we've been doing before, this is my A and that's my B. Doesn't always have to be a number. It can be an expression. Okay, and I think that's what scares students. When they see something more than just one letter, it's intimidating. But if you follow the same thing that I've been showing, this is my A, which I'll do underneath. That's my A, and that's my B. So I've got A squared minus B squared. According to the rule, it would then be x plus 2, that's my A, take away B, which is 3. And then I do it again. X plus 2 plus 3. Never leave your answer like this. So I do have some students at year 10 who get up to this step. Fantastic, but you're meant to simplify it. 2 plus 3, those are common factors or common terms, sorry. X plus 5 is there. And the last one, 2 take away 3 is minus 1. That's called factorizing using dots, even if you get those brackets there. Now, I'm not sure if the year 9s even go to that point, but I'm showing you how you can make it a bit more difficult. So if I really wanted to test you for my year 11s, for example, this is what I do. I will mix this one and this one together. This is how I do it. I would just do 2 bracket x plus 2 squared minus 18. See what I did there? I'm doing the same thing, but you can see that both have a common factor of 2. This is for year 11s, by the way, but you can still do the same problem. I might change it up. For a year 11 student who comes in, I might do something like this. 4x minus 1 minus 9x plus 3. And then I ask the students whether they can do that. So the same skill, I can make it look a bit more intimidating. Okay? You can have a go with those if you like, if you want to try out those kind of examples. But otherwise, this is the hardest. Whoops. The last one is the hardest you'll even see at a year 9, year 10. I'm almost certain that year 9s won't get the bottom one there. Okay? Year 9s will just be practicing probably the top 4. That's what you'll be doing. Okay? So I showed you some things that you might see later on. Cool? All right, there we go. I'm going to stop the video there. And for those who didn't get the notes, I'm just going to leave it there so you can copy the notes and you can watch the video again. But that's it for today's session. That's exercise 8D.